Hello everyone, this is me Ibrahim Absalam. In this video, we'll talk about digital input and outputs in logo soft comfort. The input block, it looks like that, starting by I and followed by number up to 24 digital input. Since logo maximum digital input is 24. Cursor keys, we have 4 cursor key, cursor 1 for up cursor, 2 for down, 3 for left, 4 for right cursor. And those cursor key you can find it on the PLC logo itself or its logo or on the logo extension screen TED screen. Function key, we have 4 function key. It's found in logo TED screen. As you can see here in figure, we have 4 function keys. The user can use it as digital input for logo. So if you have the TED screen connected to your logo, you can use this 4 function keys as a digital input. Output blocks, starting with Q1 and followed by number, Q1 for the first output, Q2 for the second output, and so on. Interconnect block started by X followed by number. Those blocks you can use it in transferring text messages and so on. We see in future examples. Flag blocks, in logo we have 64 flag blocks starting from M1 to 64. Some flag blocks have a specific function. For example, flag block number 29 can be used to change the logo backlight screen from white to red. Now let's have a case study. Use the 4 cursor key of logo to start stop 2 induction motors based on the following condition. Motor 1 contactor 1 must pick up and act on the left cursor and maintain itself. On action of the right cursor, the second motor contactor K2 pick up. K2 only switched on if K1 was switched on in advance. Down cursor turn everything off. Before writing program, we had to recognize how many inputs and outputs we have in our program. In this example, we have 3 inputs and 2 outputs. Left cursor to turn on motor 1. The second cursor or right cursor, we use it to turn on motor 2. Down cursor, we use it to turn off motor 1 and 2. So this is the 3 digital input. We have 2 outputs. The first output is motor 1 contactor coil, and the second output is motor 2 contactor coil. Once you turn on your logo soft comfort software, you'll have this screen. From circuit diagram 1, right click and choose properties. From input output I/O names, we'll go down until we find cursors. So cursor down, stop all. Cursor left, start motor 1 or motor 1. On. Cursor right, motor 2 on. Q1 is motor 1 contactor, Q2 is the motor 2 contactor. We can name it motor 1. Yes, motor 2. Okay. Now let's write the motor 1 turn on condition and see. So we have a cursor key, drag and drop, double click here, convert it to left cursor, and we have the shutdown we have from down cursor, and our output is Q1. Also we need one AND gate and one OR gate. Here's our AND gate and one OR gate from basic functions. Wire everything as we learned from previous example. Okay, let's simulate this part of our program. Press simulate or F3. If I press left cursor, the motor is running. Now, once I remove my hand, the latch is happen and the motor keep running. Once I press down cursor, the motor will start. Go out from simulation. We are programming using function block. We'll program the motor to control part using the ladder diagram. So convert from function block representation to ladder diagram, we just simply press on that button, convert to ladder. Now everything is similar like before. Now we need to write a program. We need to draw the ladder diagram for motor 2. First, we'll take a normal open contact and we press C to get cursor right. This is a turn off motor condition, or request to turn on motor 2. We have the stop, cursor down to stop, and we have our output coil Q2. Sorry, I dragged at the normal oil. We have our output relay Q2, and we'll need a latch from Q2. As you can see, everything now is connected. We're connecting everything. Okay, let's simulate this program. If we press left, the motor 1 is on. Press down, motor 2 is on. If I press right cursor, motor 2 is on. Unfortunately, this is not to the requirement in our program, since motor 2 have to only will turn it on if motor 1 is on. So we have an auxiliary contact from Q1 here and put it as a normally open. So by this way, we will prevent motor 2 turn it on if motor 2 is off. So it will be Q1 and place it here. Now let's simulate our program. If I press the left cursor, motor 1 will running. If I press the right cursor, motor 2 will run. If I press the down cursor, both motors will stop. Okay, if I press right cursor, motor 2 will not pick up since motor 1 is not activated. The only way to activate motor 2 by turning on motor 1 and then sending the turn on signal to motor 2. Let's see the PLC connection. So we have we only powers our PLC, and we use the 4 cursors or left and right and down cursor as additional input, and the Q1 output is connected to K1 and Q2 output is connected to K2. K1 and K2 are the coils of contactor 1 and contactor 2. So the power circuit consists of of 3-phase supply. Each motor have its own circuit breaker, its own contactor, and its own overload relays. Now let's go to our next step in this lecture. Logo soft comfort special function Miscellaneous digital. We have latching relay. The latching relay has 2 inputs, set or reset, and 1 output is Q. Once it's the set signal received, the output will become high and kept high until the reset signal is received. As you can see here, the reset signal received and disappeared. The output will kept high until the reset signal received. And as it's clear from the timing diagram. Exercise 1_2. The motor's overload signal is considered. So if motor overload signal received, this specific motor will immediately stop and will not turn on again until the reset button pressed. Okay, so to look to PLC connection to have better understand, we have for each motor an overload relay. So for example, if motor 1 is overloaded for a certain time or take much current than it's rated for a certain time, the overload will one relay will change a contactor, will change its state from open to close or from close to open. So in this case we choose normal on contact, so we receive an overload signal. Once the overload signal received, motor 1 will have to stop immediately and the user can't turn it on again until the user presses the reset button. Okay, so in this upgrade we'll have three more inputs: overload signal 1, overload signal 2, and the reset button. Let's go to our program to add this. So from here we can, from properties, IO names, we can write, we give overload 1 to input number 1, overload 2 for input number 2, and reset to IC. Okay, now from special function miscellaneous, we'll select a latch relay called special function 1, and we need two latch relays. Double click in the first one, give it name overload 1 latch, and the other will be overload 2 latch. Okay, each latch relay have its set and reset signal. So we have this contact overload signal 1, okay, and one the reset signal overload, and this is overload reset. And same thing for the latch relay 2, overload 2, and reset. Okay, so once the overload signal receives, the latch will change its state. So we'll take a contact and we'll call special function 1 latch overload latch 1. So we'll put it normally closed. So if the overload signal received, it will be set. Once it's set, this contact will change its position from normally closed to normally open, so motor 1 will immediately stop. Same thing we can do it to motor 2. And delete this wire and add a break contact here, special function 2 overload. Okay, now let's simulate this program. Press installation button. Okay, you can see here all the buttons appear as switches. We don't like this representation. I would like to represent it as a push button. So double click on simulation, in state of switch, break push button. Momentary push button for momentary push button in simulation, and third switch simulation momentary push button. Let's go to simulation again. Stop, no problem. Activate motor 1, activate motor 2. We receive motor 2 overload signal. The motor 2 will immediately stop. Try to activate motor 2, nothing happened until we press the reset signal. Try to activate motor 2, it work again. Good. Stop all, no problem. Start motor 1, start motor 2. We have overload signal in motor 1. Oops, the two motors immediately stop. So we have this wrong scenario. We expect only motor 1 is off, turn it off. So let's see what's wrong in our ladder diagram. You can see here, once motor 2, the condition, this condition is represented wrong. So if motor 2 stop, motor 1 stop, motor 2 will force it to stop because it's the position of this normal contact is here. So basically we delay this wire. I move it from here to there. So by this way, you once motor 2 will only activate it if motor 1, but if motor 1 turned off due to overload, motor 2 signal will continue running from this path. Okay, simulate it again. Stop all, start motor 1, start motor 2, overload motor 1, motor 1 is off. Try to turn on motor 1, nothing happened until we press the reset signal. Turn on motor 1 is now running. Down cursor to stop all. Thank you for watching and see you later. Bye bye.